The overall goal of this experiment is to label lymphocytes with the intracellular fluorescent dye CFSE so that lymphocytes can be monitored for cell division by flow cytometry. This is achieved by mixing lymphocytes with CFDA-SE, which is the diacetylated form of CFSE. The two acetyl groups allow the dye to rapidly enter cells. Within lymphocytes, esterases remove the acetyl groups from the CFDA-SE, forming the CFSE form of the dye. Without the acetyl groups, CFSE becomes fluorescent and is also less membrane permeant, thus concentrating the dye within cells. The aminoreactive succinimidyl side chain of CFSE then covalently couples the dye to intracellular proteins, thus making the cells almost permanently fluorescent. CFSE can be used to monitor lymphocyte division based on the sequential halving of the fluorescence intensity of daughter cells.
The main advantage of this technique over existing methods such as tritiated thymidine incorporation is that individual cells can be monitored for cell division. Demonstrating the procedure will be Ben Kwa, a research fellow from my laboratory.
In order to label cells, begin with freshly isolated lymphocytes from spleen or lymph nodes of mice and add a concentration of between 0.5 and 10 million cells per milliliter of culture medium, supplemented with 5% heat-inactivated fetal calf serum. Thoroughly resuspend the cells and carefully transfer 1 milliliter to the bottom of a fresh 10 milliliter conical tube. Lay the tube horizontally. Carefully add 110 microliters of PBS to the top of the tube in the non-wetted portion of the plastic, ensuring it does not make contact with the cell solution. Add fresh dye solution of 1.1 microliters of the 5 millimolar stock of CFDA-SE to the 110 microliters of PBS. Quickly cap the tube and invert and vortex well to get quick uniform mixing of the solutions. Since the dye becomes fluorescent and thus prone to bleaching, protect the tube from light by covering the tube with aluminum foil. Incubate the cells for 5 minutes at room temperature. Wash cells by diluting in 10 volumes of 20 degrees Celsius PBS containing 5% HIFCS, sedimenting by centrifugation at 300 Gs for 5 minutes at 20 degrees Celsius, and discarding the supernatant. Repeat the wash twice more. Cells can then be applied to a protocol of interest for induction of cell division. Labeled cells can be used in both in vitro and in vivo assays. At the completion of the proliferation assay, cells are harvested and analyzed by flow cytometry. In this example, CFSE labeling is used in vitro to measure how T cells from genetically modified transgenic mice respond to dendritic cells pulsed with different concentrations of antigen. The unshaded CFSE dilution peaks depict transgenic CD8-positive T cells that have divided 1 to 3 times. It can be seen that more T cells divide at the higher concentrations of the antigen. The CFSE labeling method is also amenable to in vivo assays, like adoptive transfer experiments. Here, FACS is used to identify the population of T cells that are of interest in recipient mice. A subsequent CFSE proliferation profile depicts CD8-positive T cells that have divided 1 to 6 times, based on CFSE dilution peaks.
After its development, this procedure paved the way for researchers in immunology to explore lymphocyte proliferation during an immune response.